Let's solve this equation. Y prime equals e to the x over y, and y of 0 equals 1. All right, so let's take a look. First, write this as dy dx equals e to the x over y. So we can separate variables, that's why. And actually separate them. So you're going to have y dy is equal to, yep, e to the x dx. Now anti-differentiate both sides. So y dy equals e antiderivative, that is, of e to the x dx. Now actually anti-differentiate, so you will have 1/2 y squared. So just use the power rule on the left side. It's y to the first like this, right? So 1 plus 1 is 2, and then 1 plus 1 in the bottom is also 2. So it's 1/2 of y squared. Then it's equal to e to the x plus c. Now you can just apply the initial condition. Y of 0 has to be equal to 1. We're told here. We just made that up. Okay, so let's do that next. You will have 1/2 of 1 squared, that is, right? So plug in y equals 1, and it's equal to e to the 0 plus c. Then you solve that. So for c, that is 1/2 is equal to 1 plus c. E to the 0 is 1. Subtract 1, so it's going to be negative 1/2 as the value of c. So that's done. From there, now we get the equation as follows. 1/2 y squared is equal to e to the x minus 1/2. So that's an implicit solution, but here you can solve for y explicitly. So you can do that by multiplying every term by 2 this way. Okay, so multiply the left side by 2, and the same thing here. Multiply the right side also by 2. So because we want to get rid of the fraction on y squared. So 2 times 1/2 is 1, so you have y squared. Then 2 times e to the x is 2e to the x. 2 times negative 1/2 is negative 1. Now, to get rid of the squaring, just take the square root of y squared. Do the same thing on the right side. Just be careful, make sure you use a plus or minus. So 2e to the x minus 1. But we know also that on the left side, this is y. We have y of 0 has to be equal to 1. So if the plus and minus, we can just take the plus for that reason. And 2e to the x minus 1 is what we have. This is then the explicit solution. Now we have to be a bit careful. Let's look at a graph here and understand where this is defined. So graph it. So the positive root there of, let's see, 2e to the x minus 1. So that's this graph right here. Now look what happens right here at this value of x. Well, if you just look at this is just a function. So in other words, you would have to have 2e to the x minus 1 greater than or equal to 0, like this, okay? Greater than or equal to 0. That would be one condition, just by looking at this as a function. But however, because the stuff is coming from a differential equation here, you have to also observe that an e to the x over y, which is the expression that defines the differential equation, like y cannot be equal to 0, correct? Because we do not divide by 0. So that's important because that tells us that the real condition is 2e to the x minus 1 is strictly greater than 0. Cannot be equal to 0 because if x has this particular value you're about to find, then y would be equal to 0, and then the differential equation itself, e to the x over y, would not be defined. Okay, you cannot, let me stress, right? Can't have this part present, the equal to part, because if the x were actually equal to whatever this is about to be equal to when I solve it, if you did use the equality part, then you can tell from the graph that y there would be equal to 0. That would make e to the x over y undefined. So you have to have this condition for that reason. 2e to the x, and then greater than 1, add 1, and then e to the x is greater than 1/2. Then you take the natural log of both sides, so ln of e to the x is greater than ln of 1/2. Then you solve this, so e to the x, when you take the ln, is just x, and this is greater than ln of 1/2. Now, ln of 1/2, if you know anything about the behavior of the ln function, hopefully you know this is a negative value, like this. So let me just kind of estimate it, ln of 1/2. Okay, so you punch this in, you see this is a value of about negative 0. More or less, negative 0.693. So that's this value. I'll type it in the exact form, but you know the approximation now is also, so that value of x, that's about right here. See, that's the value of x, right there. So one more time, let me repeat. If you plug this in here, then look what happens, right? Y would be equal to the root of 2 2e to the ln of 1/2 minus 1, like this. Okay, that is if you were to use ln of 1/2 itself, okay, by using the equal to part from this inequality. Okay, so then you would have, well, e and ln are inverses, so you would have 2 times 1/2 minus 1, see, but that would give you 2 times 1/2 is 1 minus 1, which is then the root of 0, which is 0. But we can't have that because e to the x over 0 would not be defined in that case in the differential equation, you see? So that's why, let me stress, you need just the greater than part. That's enough. So if it's been helpful, interesting, insightful, friends, please be sure to leave a like. Thank you so much for watching. I will see you in the next one.